Welcome and thank you for standing by. At this time, all participants are in a listen-only mode. This call is being recorded. If you have any objections, you may disconnect at this point. Now we'll turn the meeting over to your host, Michael Hawes. You may begin.
Hi, good afternoon, everyone, and welcome to the fourth webinar in our series on understanding the 2020 Census Disclosure Avoidance System. Today's presentation will explore the highlights of our recent demonstration data release, the April 2021 Detailed Summary Metrics. And today's presentation will be given by Matthew Spence, a Senior Advisor in the Census Bureau's Population Division. Next slide, Matt. Great. Before we begin, I just want to acknowledge the contributions of our colleagues here at the Census Bureau and our external partners. They're listed here. I also want to acknowledge and thank our many external stakeholder groups that have been contributing feedback to us that have helped us with the design and improvement of our disclosure avoidance system. I want to state that any opinions and viewpoints expressed today are entirely the presenter's own and don't represent the opinions or viewpoints of the U.S. Census Bureau. We're also joined today by our colleagues Megan Mowry and Michelle Hedrick. They will be helping us to answer some questions. If you have questions during the presentation, please type them into the Q&A feature of the WebEx platform, and we will be replying to those throughout the presentation, and then we'll have some time at the end for answering any remaining questions that we haven't gotten to. And with that, I would like to turn it over to Matthew Spence to give today's presentation.
Hi, everyone. Thank you, Michael. As mentioned, my name is Matt Spence. I'm the Senior Advisor in the Population Division. And our role in the Population Division and the Demographic Directorate more generally for these tests of the disclosure avoidance system has been one where we're trying to evaluate sort of fitness for use. Much like our external stakeholders, we're interested in the accuracy of the data. We're interested in whether there are any sort of statistical bias or, sort of clouds of outliers, that sort of thing. So in an effort to measure these characteristics and an effort to sort of quantify them in a way that we could easily use to summarize fitness for use, as well as compare across different runs, potentially different parameter settings, we came up with something called the Detailed Summary Metrics. Our initial runs were sort of a bit limited, sort of focusing on the main bits of characteristics or total populations. And then in consultation with our external stakeholders, we've added to it immensely. And so now I'm going to be walking through these metrics for you to sort of illustrate how you can use them, how you can download them and take a look for yourself, and use them to evaluate these latest runs of the disclosure avoidance system. So what are these metrics? So these metrics compare tabulated quantities for a given geographic level for a DAS run to the published data, to the swapped data. So for example, we'll look at like total population at the county level, or we'll look at the Asian alone population at the tract level. And we'll do things to look for measures of accuracy, bias, and counts of outliers. In particular, we will be focusing today on the mean absolute error, or MAE. And the MAE, I'm going to go into that in a little bit, but basically it's a measure of what's the average change, plus or minus, what's the average difference or error you should expect to see for a given tabulated quantity for a particular set of geographies. We also have statistics on things like mean absolute percent error, which looks at a relative measure. So what's the sort of percent change, plus or minus 1%, plus or minus 5%. We do have some measures of bias, which I'll be covering, sort of directional change. Do quantities tend to increase for this characteristic or tend to decrease? And then finally, we look at counts of outliers. So we're interested in not only are the overall metrics getting better, but is it possible that certain runs of the algorithm or certain parameters are leading to an increase in the number of just really out there cases, really strange outliers. So we'll be covering all of those in the next few slides, the next few minutes. So the first thing to note is just a brief introduction on how we calculate these metrics. So what I've got here is a list of all of the counties in the stateside United States. So all 3,143. This is obviously an excerpt. And we have the published 2010 population. And then we have, this is the population that is the result of the application of the disclosure avoidance system, what we're calling the PPMF, or Privacy Protected Microdata File. So this is, what would be tabulated to create all of the tables. So you can sort of imagine it like this is the sort of, in a way, the true value, and this is the privacy protected value. Not exactly right, but, that suffices. And so what we can see is there's the error. So that means that there's 10 more persons in this county than there were in the actual published 2010 data. And that is an absolute value of 10. Next, for Baldwin County, you can see that there are 2 fewer persons in Baldwin County than there were in the published data, and the absolute error there is 2. So what you do is you repeat that for all 3,143 counties, and you take the average, and that is the mean absolute error, or 4.91. So what does this mean? This means that on average, for a particular county can expect to gain or lose about 5 people. And you can see, here's Loving County in Texas. They had 82 persons in the published 2010 data. After the disclosure avoidance system, they would have had 77 for this latest run. And so they would have lost 5 people. And that's an average outcome for, what we're seeing for these runs. And that is reflected in the spreadsheet, that's 4.91, that we'll be going through in just a second. You can see that is just very clearly summarized as MAE under the all counties total population. So table 1A, total population for county size categories. This is for all counties. The mean absolute error is 4.91, just as we saw before. So what about MAPE? MAPE is another key measure of accuracy. MAPE is the mean absolute percent error, and it's calculated in a very similar way. The only difference is that it's percent change instead of absolute change. So, again, looking at the list of counties, we can calculate what's the percent error and then take the absolute value. So taking Loving County as an example, we can see that Loving County decreased by about 6%. Its population declined by about 6% as a result of the application of this top-down algorithm. That absolute percent error is about 6%. But when you take the mean across all 3,143 counties, that ends up being 0.04%. So the average county gains or loses about 0.04% of its population, which is very, very close to 0. In general, these accuracy metrics, 0 is sort of absolute accuracy, the target you're shooting for the target you're sort of aiming toward. And we can see that 0.04 reflected in the MAPE column of table 1A. And so this just sort of gives you an idea of how are these metrics calculated and where can we find them in the spreadsheet. We'll be going through the spreadsheet in just a moment. But before we do that, I wanted to address outliers. Outliers are something that we added, we actually had in our original versions of the detailed summary metrics, and we added additional measures of outliers in response to stakeholder feedback. I think a lot of stakeholders are concerned that, what's the worst case scenario? What's the least accurate? What's the biggest change that we can expect as a result of the application of this method? So we introduced these counts of outliers, and in general, the cutoff that we keep using is a change in the absolute percent of 10%. So we can see here, this is now looking at race alone and then 2 or more races. So of the 3,143 counties, how many of those counties saw an absolute percent difference change for that population exceeding 10%? And so, you could see one of those counties, in one county, the white alone population changed by more than 10%. And then in 743 counties, the black alone population changed by more than 10%. And so some people have sort of, been concerned that this necessarily means that, one statistic or one group is getting a more accurate treatment than the other. And in fact, I put the sort of percent of all units over here to kind of give a sense for what folks have been asking us about. There are 0.03 of the counties have that outlier for the white alone population, but 67% of counties seem to have that outlier for Native Hawaiian or other Pacific Islander alone. And so it does seem like certain groups are less accurate than others. But the thing to keep in mind is that the average size for these different groups really radically is different. So here, I put in the average population size for these different groups. So for the white alone population, the average population at the county level is 77,000. And then for the NHPI alone population, the average population is 172. So, from tens of thousands down to the fewer than 200. It's a very big swing in population size, and that means that it's a lot easier to hit that 10% threshold for 172 persons as the base versus 77,000 as the base. So this is just something to keep in mind that, as we're going through and looking at these outliers, try to keep in mind what is the expected sort of population size of that particular cell. And so one thing we can do is we can use size cutoffs and sort of hold size constant in order to, sort of look between these outlier counts. So one of the things we calculate are, incorporated places outliers. And we can say, let's look at all the incorporated places where the characteristic population is between 0 and 9 persons. So, there are 99 incorporated places with between 0 and 9 persons who are white alone. There are about 9,300 incorporated places where the black alone population is between 0 and 9. And, what you can see is now just looking at those 99, 89%, 89 of those have an absolute percent difference exceeding 10%. So that's, nearly 90%. Nearly 90% of those incorporated places with very small white alone populations have that very big swing in the white alone population. Whereas for the black alone population, it's only about 64% of those incorporated places. So only of the 9,300 incorporated places that have very small black alone populations, only 64% of them have that population change by more than 10 percentage points. So that's something to just sort of keep in mind as we're looking at these going forward. A couple of other notes as we're looking. Dashes in general mean 0. There were several times where we're seeing zeros, and if you see a dash, that means 0. If you see blank values for an entire table, that just means that the table can't be calculated from the data that we've produced, the PL 94-171 data that we've produced. So things like householder characteristics, detailed vacancy, or single year of age, those we can't calculate yet given the data that we've produced. And as I've mentioned, keep in mind that percent errors are sensitive to population size, and that outliers, are frequently measured as a percent error threshold. So with all that, okay, that's a lot of information, but let's just dive right into the data. So if you go onto our website and you find the detailed summary metrics, these are the ones from the April 28th release. These are the ones that we've been discussing over the last several webinars. But they, just as a quick recap, These are the ones that are at the global privacy loss budget of 12.2. You can see that in the 12-2 in the file name. And that epsilon is, high enough to satisfy the redistricting use case that was described in previous webinars. So I will, encourage you to go back and look at those, those webinars to understand those redistricting use cases. But in general, you can say that these targeted very small populations to ensure that the largest race or ethnic group stayed within 5 percentage points 95% of the time. They're targeting very, very small block groups, places, and MCDs, just to really ensure that those, were tightly bound for race groups. So this is the first tab. It's the README tab. It discusses some of, the changes that have been made, and importantly, it asks for feedback here, and we will, of course, show this email address again, but 2020-@census.gov. That's a great place to give us feedback about if there's a use case that we're missing or a calculation that you'd like to see us make, or any other feedback about, targeting fitness for use. So the second tab here is a list of tables. We have 4 different sets of tables. So we've got the basic demographic accuracy profile, basic accuracy profile, essentially. We've got, various tables here. We've got specific use cases. We have the full demographic and housing characteristics file use cases. Now, these are ones that, as you'll see, are like tenure or, household, type. Those are not quite available yet. Those will be filled in once we have the DHC data and demonstration products later on. But for now, we included them from our stakeholder feedback, but unfortunately, they will be blank, as we'll see. And then the last set of tables, the last tab, are the impossible and improbable results use cases. So these are things where, they're just impossibility results. And we'll see all of these in turn. Let's start with the third tab. The third tab is really sort of the heart of these detailed summary metrics. These are where you're going to find statistics on, like I said, accuracy, bias, and outliers for both total populations as well as characteristics populations. It's a lot to sort of take in. As you can see, it's filling up my whole screen. And, in general, you can see that each table is its own sort of entry. Each table, has a specific item, data item that it's mentioning, sort of, what characteristic is it measuring. Here it's total population. It has a specific geography, and here it is counties at the county level. And, frequently it also has a breakup by size categories. So one thing that I like to do is you can see here that there are a lot of different variables used. We've got counts of units, mean absolute error, RMSE, MAPE, CV, MALPE, and then 3 columns counting outliers. So this is a lot of information. So what I will frequently do is, although, I love our economist friends, I typically will hide the, or just even delete these columns for RMSE and CV. That just makes it easier, and everything sort of shows up, on the same page. And, really, mean absolute error and MALPE and MAPE all kind of get at the same sort of information. So that's what I'm going to do. I've done that already for these tables here. I've just sort of gone through, and it's the exact same tables that you can find online, but I've just sort of deleted those columns that, to me, I'm not really going to focus on. This will just make it easier for everyone to sort of see. Okay, so we've already started to take a look at Table 1A, total population for county size categories. As we say, this is the total population, and this is at the county level, 050 if you're into summary level jargon. So for all counties, all 3,143 counties that are stateside, as we saw earlier, the mean absolute error is 4.91. And so that means that the average county changes by about 5 persons, gains or loses about 5 persons as a result of this disclosure avoidance application. Here's the MAPE. As we saw, that was 0.04%. And so these statistics we've sort of seen already. We sort of walk through how to calculate them in the slides. In the remaining rows, we break up these 3,143 counties into size buckets or size categories in order to sort of see what is the differential effect of this top-down algorithm. What's the differential effect of this disclosure avoidance system based on this, for the smallest and the largest, for the least populous and the most populous. And so you can see here for counties, there are 35 counties that have a population of less than 1,000, and we include these metrics for the smallest counties. And then we sort of step it up. We have 1 to 5,000, 5 to 10,000, 10 to 50,000, 50 to 100,000, and then the largest, most populous counties, 100,000 or more. So there are 578 counties with populations of 100,000 or more. So these are like, LA County and the like. So one thing to note is that the mean absolute error stays about the same despite the differences in, population size. So the smallest counties gain or lose about 4 people, and the largest counties gain or lose about 5 people on average. These are very, very small overall, but they're, particularly relatively very small for the largest counties. The reason for this mean absolute error remaining just about constant is because of the nature of the top-down algorithm and the fact that these geographies are considered the on-spine geographies. If you've attended some of our other webinars, you've heard talk about the on-spine geographies and some of the off-spine geographies. County is one of the on-spine geographies, along with state, tract, block group, and block. We can also see the sort of relative change. That plus or minus 4 people is, about 0.75% gaining or losing for the smallest counties. But by the time you get to the very largest counties, it rounds to 0. That plus or minus 5 people, when you're talking about a base of 100,000 people, it's about 0%. It really rounds to nothing. And then one last thing, I'll skip MALPI for now, just because I want to focus on a couple of other things. But, looking at the counts of outliers, we have a couple of different measures of outliers. We've got 2 to 5%, exceeding 5%, and then exceeding 200 persons. And what we can see are a lot of dashes, a lot of zeros. There are 0 counties that have an absolute percent difference in their total population between 2 and 5%. That's great. We have 1 county that has the absolute population or percent difference exceeding 5%. And we saw that already in the slides. That's Loving County, which lost 6% of its population. And it is one of the smallest counties. That's why it shows up here in the smallest county row. And then we have no counties that have a total population difference exceeding 200 people, either plus or minus. That's sort of the basics on how to read through these detailed summary metrics. Let's dive into a couple more. Table 1B shows incorporated places. Now, incorporated places are what a lot of us think of when we think of our hometown. These are cities, towns, political and legal entities that frequently will cross tract, block group, and sometimes even county lines. So these are considered off-spine geographies. There were 19,540 in the 2010 census. And as you can see, the mean absolute error was about 21. So what does that mean? That means that the average incorporated place gained or lost about 21 people in terms of their total population. We can see the MAPE. That means that, the average incorporated place gained or lost about 1.2% of its population. And you can be the judge about, is 1% gain or loss, substantively large? Does that sort of not quite meet, what your standards, your fitness for use standards should be? But I can tell you that it's an improvement over our prior runs, and we'll go more into that in a little bit. Here we also have some counts of outliers. You can see that, of the 19,540 incorporated places, a little under 10%, so about 1,800, about 1,900 of them had an absolute percent change of their population between 2 and 5%. And then an additional 705 incorporated places saw an absolute percent difference exceeding 5% for their total population. And then finally, sort of as a separate measure, about 302 of those places saw an absolute numeric difference of more than 200. So they saw a gain of 200 plus or a loss of 200 plus. Here we also kind of go into the different size categories. Here we've broken up 1,000 into two separate groups because, as you can see, there are a lot of these incorporated places that have population of less than 500. Of the 19,540, 6,000 of them have, total populations of less than 500. Very, very small units, geographies there, or less populated, I should say. And then we go up to 100,000 or more. Now here's something to note as you're sort of scanning down these rows. You can see that the mean absolute error, unlike with counties where it was all about 4 or 5, here it very much increases with the size of the total population. And that is just sort of the nature of these off-spine entities that I was mentioning. These places that kind of break across tract lines are considered off-spine, and due to the nature of the top-down algorithm, you'll see that the mean absolute error does increase along with population size. However, that doesn't necessarily mean that the noticeable amount of error is really going up. In fact, it might be the opposite. You'll see that the MAPE continues to decline as the population gets larger. So for the smallest incorporated places, those populations fewer than 500, the average change was about 2.8%. So these very, very small places, 400 people, 300 people, gained or lost on average about 3% of their population. And then the largest places, those with 100,000 or more, the most populous places, had a gain or loss of about 0.15, so about 1/10 to 2/10 of a percent. So the relative error, as measured by mean absolute percent error, or MAPE, has gone down with population size, and that's very similar to what we saw with counties. Now, one thing I'll point out here is MALPI. Now, MALPI, mean algebraic percent error, instead of absolute. That's the AL, algebraic. This measures the directional change, the average directional change. So what we can see is that, for the least populous incorporated places, it has a positive number. It sort of, on average, these small places tend to gain about 0.75% in their population. And then the larger or more populous incorporated places actually tended to lose population, 0.09, 0.08, very, very small on average, very, very close to zero. But still, you can kind of see this is what we use to look out for bias. This is something that we saw in the October 2019 release in particular. The very first set of demonstration data back in 2019, we saw a significant amount of this bias where the least populous areas tended to gain in population and the most populous areas tended to lose in population. And so we've really taken pains to address that and really try to minimize that. So we do still see that, but we are doing our best to minimize that. Okay, so what else? So these were so far looking at total population for counties and incorporated places. As I'm scrolling through here, I'll just kind of stop and address a few. You can see that we've got total population for tracts as well. Here we've got total population for blocks. We don't typically focus on block level data for these metrics, but we did want to sort of address the urban versus rural. So all of these are the urban blocks, sort of all 5 million of them, kind of looking across all 5 million of them. These are all of the rural blocks, all 6 million of those, and we can see that the mean absolute percent error is about the same for both. We have separate statistics for Puerto Rico. The municipios and the tracts in Puerto Rico are tabulated separately, and you can see, but in general, they look very much like the county and tract level. As you'll remember, it's 4.91 for stateside. It's 4.36 for MAE for Puerto Rico, county equivalent geographies. We also have additional geographies that were, asked for stakeholders, by stakeholders. Here we've got, different school districts. We've got, elementary school districts, secondary school districts, and then unified school districts. And once again, we sort of break them up by size, so we can see, what are the impacts by different size categories. In general, these are off spine, and so they do look a lot like incorporated places in that the mean absolute error tends to go up with population size. And generally, as always, the relative error tends to go down with population size. We also look at minor civil divisions. We look at some AIAN areas as well. Here's Federal American Indian Reservation and off-reservation trust lands. This is one where we've gotten some great feedback, and so we really do love hearing feedback about this. We can see that on average for these Federal American Indian reservations, they gain or lose about 11 people when you're looking at total population, which is about 15% of their population. We do look at Oklahoma tribal statistical areas and Alaska Native village statistical areas as well. And then we start to get into some of these other characteristics data. So now this is voting age population, or total population aged 18 and over. And we do this for many of these geographies. I'm going to scroll down though and get down to Table 3. So Table 3 is looking at we run, not only do we run person level data and have a person level file, we also run unit data and have a sort of a housing unit / GQ level file. And so the unit file is where a lot of some of the most interesting statistics are located. So for PL, these are purely limited to occupied, count of occupied, and count of vacant units. But once we ramp up for the full DHC, that's when we'll have statistics like characteristics of a householder, household type, presence of children, and other things like that. But for now, we're looking at occupancy rate. Again, we look and see. So the MAE here is 0.28, but the sort of statistic is occupancy rate. So that it means that the occupancy rate changes by about 0.28. So if you imagine that the occupancy rate is 80%, it might go up to 80.28%, or it might go down to 79.72%. Is that right? Yeah. We also show occupancy rate for incorporated places. We can see that it's slightly higher for incorporated places. It's 1.88, which means that on average that occupancy rate will change by about 2 percentage points, plus or minus. Then we do this for various others, including Puerto Rico geographies. And then Table 4 starts to look at some of these persons per household. So, these persons per household, this is, taking the number of persons, in a household from the person level file and dividing it by the number of occupied housing units on the unit file. Now, we're gonna get into that in a little bit in some of these, in the final tab. We have some great data there. But in general, we can see that on average, the persons per household doesn't change by that much, 0 for the counties on average. Although we do see that, 12 counties had an absolute percent difference exceeding 5%. All right. Table 5 looks at Hispanic or Latino origin for various levels of geography. You can see that, for example, at the county level, the mean absolute error is about 25 for both the Hispanic population and the not Hispanic population. That sort of translates into different MAPEs, different relative amounts of error, just because, again, these percent errors are sensitive to population size. So, that 25 persons gaining or losing translates into about 5% of the population at the county level for the Hispanic population and about 0.15% for the not Hispanic or Latino population. But really that has a lot to do with the average, size, the average population size at the county level for these groups. So though, it's really good to look at, and we really do welcome any feedback you guys have about this. Table 6 looks at race alone. Here we're looking at race alone at the state level. And then here I'll just skip down to 6B, which is looking at race alone for the county level, at the county geographic level. And so this is where we've sort of collapsed race into a category, much like a lot of demographers do. Most demographers don't look at the 63 different race categories sort of all separately. They'll collapse and combine. So here we've taken the sort of major race groups alone, and then we've collapsed any 2 or more races into a single category. And what you can see is that at the county level, the mean absolute errors sort of vary. For the white alone population, it's about 20. The black alone population is about 15. For the Native Hawaiian Pacific Islander alone population, it's about 5. And then for 2 or more races, it's about 22. So, on average at the county level, you'll see, about 22 more or 22 fewer persons who are 2 or more races, to give an example. And we can see that those, again, do have different MAPEs due to different population sizes. But, it's something to be aware of as you're looking at this. That 71% MAPE that implies that means that the average county saw its Native Hawaiian Pacific Islander population changed by 70%. But keep in mind that's only a change of about 5 persons. So it's really helpful to look between the two, MAE and MAPE. I just want to address a couple more issues. So as I mentioned, we looked at race alone here. We also look at, in Table 7, race alone or in combination with 1 or more races. That's another way that demographers and others will sort of look at race data. They'll say, if you're white alone, or if you're white and black, or if you're white and AIAN, you would be counted as white alone or in combination. Likewise for these other categories. And you can see here that once again the mean absolute error is approximately the same. You're gaining or losing somewhere between 12 and 22 people at the county level for these different race groups. So just skipping ahead, I really encourage you to look at all this. We took a lot of great feedback from our external stakeholders. As I mentioned, you'll see that some of these detailed ones that rely on single-year age are going to be blank, simply because we just don't have the data in the PL data to address this. But we do have data on things like GQ populations all the way at the bottom. So really interesting to see how do these GQ populations change as a result of the application of disclosure avoidance. Another tab that is interesting are these updated use cases. A lot of these are going to be blank because they are use cases that were suggested to us by external stakeholders. For example, this top one was suggested they needed very small geographic measures of the very elderly, high risk, very vulnerable populations. So they asked us to tabulate the population age 75 and over at the tract level to sort of see how much impact the TopDown algorithm would have on these populations. But unfortunately, single year of age is not included in PL, so we're not able to calculate this. These couple of tables look at the total absolute error of shares. I'm not going to go into that. It's pretty technical, but there's a great supporting document that discusses these measures. And then, unfortunately, as I said, a lot of these are just going to be blank for now, but stay tuned for the DHC data, demonstration data. We'll be able to fill these in. Likewise, for this tab here, full DHC use cases, a lot of these are just not data that are being produced yet. So I'm going to skip to, I want to leave enough time for questions. So I'm going to skip to the final tab, which is impossible and improbable metrics. So what we tried to do here was we tried to summarize the fact that, the person data are being run separately from the unit data. That's just the nature of the top-down algorithm and the application of this disclosure avoidance. And because of the randomness and the noise injection, there may be cases where we see somewhat disjointed outcomes between the two different files. And so that's what we're trying to look at. So we have a couple of interesting ones here. Table 2. Are there any households that outnumber the household population? We see that there aren't any. So that's great to see. But for table 3, this is one where let's look at the number of blocks where the household population is less than the number of occupied housing units. So if you sum up all of the household population from the person level file, you keep that in mind, and then you sum up the number of occupied housing units from the unit file, and then you compare the two at the block level, this is, an attempt to measure, how many of those blocks have a household population less than the, number of occupied housing units. So we can see that, over here on the left, this is as it was published. So we're only looking at those blocks where there was at least one occupied housing unit. So there were 6.1 million of those in 2010, and none of them met that case where there were, there was less household population than occupied housing units. Here in the latest PPMF, we can see that about 3.6% of blocks have this sort of impossible or improbable characteristic where the household population is less than the number of occupied housing units. We have another sort of measure here where, looking at the blocks where the household population is equal to or greater than 1, where the number of occupied housing units is 0. So these are blocks where, there are just no occupied housing units, but there are some persons in households. And what we can see here is that there are 10% of blocks where there's at least one person in a household have 0 occupied housing units. So that's one area that we're going to continue to be looking at these sorts of inconsistency measures. Just skipping ahead, a lot of these, unfortunately, do sort of rely on the DHC data, like household type or family relationship type, or single year of age. But one that I wanted to spotlight was number 18, where we're looking at blocks with a population all age 17 and younger. So these are excluding blocks with GQ population. So any block that has GQ population is dismissed. And so these are only blocks with household persons. And we can see that about 1.5% of them, 1.5% of these blocks with no GQ population have everybody age 17 or younger. So those are a couple of the impossible and improbable metrics that we've seen for our detailed summary metrics. I encourage you to kind of continue to look at these. Oh, and we also finally will have a table on persons per household. We heard from stakeholders that sort of the threshold of concern is where the persons per household is greater than 10 for a given area. So this is counting the number of blocks where there are more than 10 household persons per occupied housing unit. So one of the nice things about these detailed summary metrics is that you can, kind of easily get a sense for, well, on average, I'd say that the total population numbers look pretty good. You're gaining or losing about 5 people at the county level. Just sort of thinking about what I know about counties, what I know about total populations, maybe I might come to the conclusion, well, 5 people plus or minus at the county level, that's actually not that much of an impact. But you can still see, areas where, work might still need to be done and additional focus might need to be made, such as some of these other metrics. So that's really nice to see. Another nice thing is that you can compare across runs. And so you can see, since 2019, what's the story on accuracy. I'm just going to quickly run through a couple of these slides just to sort of show you sort of our journey. So here we're looking at, again, county total population, and we're graphing the MAPE, the mean absolute percent error. And we've got, on the horizontal axis here, we've got the different demonstration product vintages. So the first one was in October 2019, and the latest one is April 2021. And on the vertical axis, we've got the mean absolute percent error going from 0 to 0.8%. And what you can see is there's a remarkable improvement in a county total population MAPE. We also put a little note about what this translates to in terms of actual numbers of persons. So we've seen a lot of improvement there. Here, we're looking at the smallest counties, just focusing on those counties with total populations under 1,000. You can see a significant amount of improvement. Here, the MAPE was well over 25%, or like 28%, and here it's about 1 or 2%. That's a much a lot of improvement for these least populous geographies. Here we're looking at places. So again, these are sort of incorporated places that are off spine. We can see that in October we were showing about 10% error on average, and now we're seeing less than 2% error, about 1.5% error. And we're seeing that improvement in the smallest incorporated places as well. Population under 500, it's gone from almost 20% to about 2.6%. And then my final slide is showing, just looking at the counts of outliers. Here are the places that exceed a 5% error for total population for incorporated places. You can see that, nearly 8,000 of them, of the 19,000 total, so almost half of them, had that greater than 5% error, and now it's below 1,000. So we are, sort of trending in that right direction in terms of increased accuracy. And with that, I'm going to turn it back over to Michael.
Great, thank you, Matt. And before we turn to answering some of your remaining questions, I just want to encourage everyone to Tune in for our final webinar in this series next Friday, which will be an analysis of the April 2021 demonstration data for the Redistricting and Voting Rights Act use cases. So please stay tuned for that. Next slide, please, Matt. And if you haven't already, please sign up for our disclosure avoidance and data products newsletters. We provide updates every week or two on the latest news about our modernization of disclosure avoidance and the disclosure avoidance system. You can sign up for that just by going to the census.gov website and searching disclosure avoidance. And next slide. And finally, if you want to learn more about the topics that we've been discussing today and our work on the disclosure avoidance system, there's lots of great resources on our website. We've got videos, blogs, fact sheets, frequently asked questions, and much, much more. And if you have feedback on anything that we've been discussing today or on our whole modernization initiatives, or if you've been analyzing the demonstration data for yourselves and you want to submit your analyses for us to review, please email that to 2020-@census.gov. And with that, we're happy to answer some of your remaining questions, so I will turn things over to Megan to moderate for us.
Why, thank you, Michael, and thank you, Matt. There are about a few too many questions that we have time to answer, so what I'm going to do, Matt, is try to give you the sort of 5 or 6 themes that showed up in the Q&A so far. And if you could give me a shorter version of your answer, and then we'll try to follow up with people as best we can if they want more detailed responses. So I would say the first big theme is the question of why you're comparing the differentially private data to the 2010 swapped data rather than to the data that we have that doesn't have disclosure avoidance applied to it.
That's a great question. So, when we were discussing these metrics, obviously the most correct thing to do is to take the private data, what we call the CEF data, which has an edited file, the actual, edited, ready to go private data, and compare the distance or the accuracy from that, to the DAS. But that meant that every time we wanted to release detailed summary metrics, we'd have to go back to the Disclosure Review Board because it would be sort of leaking additional privacy from the CEF. And it also meant that data users, such as yourselves, wouldn't be able to sort of really duplicate our work. We really wanted to be able to have folks sort of see what we were doing and be completely transparent. So because we decided to compare against the swapped data, that means that people like IPHMS and David Van Riper can release tabulated data from the PPMF and put that alongside SF1 data, published 2010 data, and people can do the math themselves and double check our numbers and see, oh yes, that makes perfect sense.
Yeah, I love that. And connected question, which I think is an important question, is how we're helping people understand that the comparisons are to the swap data and not that CEF data. And I'll just answer that from a communications perspective. We're doing our best to make that clear to folks. We recognize not everyone understands that differentiation. So just to pull from the actual question, someone mentioned that some people are doing this comparison and assuming that the top-down algorithm is performing worse, but it's possible that 2010 census data has more noise than the top-down algorithm. We won't know that unless both data are compared to the unaltered data. Unfortunately, as Matt said, we really struggle with, we didn't want to further degrade the confidentiality protections from 2010, so comparing to that unswapped data puts us in a tough spot. But we're doing our best on a communication side to follow up and make sure that people are aware of that distinction. So jumping into the next theme of questions, there's a couple questions in the Q&A that are questions I think you answered in your chat, like in your conversation, like there was a tendency in the prior demonstration products to undercount urban areas, overcount rural areas. Matt talked us through some of the metrics there. There were also questions in the Q&A about, there wasn't age data available in these demonstration products. Will that be out later? The answer is yes, as Matt talked about. That will come to us later in the process. One really interesting question in the Q&A was, are there regional differences in the dynamics that you described here, Matt, or are the differences similar for similarly situated geographies across the country?
What we've noticed, we've done some mapping, we've done some looking at sort of how these data look by other sorts of cross tabulations, and really the primary thing that we wanted that stood out to us were the size categories. It really wasn't a question of region. It was a question of, these places tended to have, less populous incorporated places or something like that. So that is sort of what we saw. I'm going to try to put this on the web. I think that it's not showing up here. Actually, now you can see it. I wanted to highlight that David Van Ripper of IPUMS and NHGIS very nicely has been tabulating these demonstration data, and you can see that we've got back down to May, but the most recent release is the 0428, April 28th of 2021, 12-2, and you can pull down individual level tabulated results. And it'll come up with a zip drive like this, and then you can use that to actually open up individual level data. I think you can see this. Yeah, individual level data that you can then use to sort of dive into patterns yourself if these detailed summary metrics are not sufficient, or if you really want to get a closer look at the data. So you can really we can see exactly what the total populations were under what he's calling DP, for what he's calling for differential privacy, but it's a top-down algorithm, the DAS. And he also includes, over here on the right, these SF tables, or, the published data. So you can easily calculate any metrics you'd like yourself if these summary metrics are not sufficient.
That's great. Thank you so much, Matt. That's super helpful. The other two big themes, one was really about how to interpret this data. And then we've gotten this question in a number of our webinars in this series. Folks want to know, when the data are ultimately released, will we give them some sort of confidence interval or some type of deviation number so that people can know how to use the data that we publish? And I know the answer, but Matt or Michael, would you mind just telling folks aloud a little bit more about that?
So, Megan, I apologize. I was answering questions in the chat, and I missed your question.
Oh. Would you mind just, a bunch of folks in the Q&A were asking about our plan to release any kind of confidence interval or deviation numbers that will help us understand how to use the data.
So, yes. So that's an excellent question, and it's one we get a lot. The Census Bureau, as I mentioned in the answers to some of the questions in the chat, the Census Bureau has committed to publishing guidance for data users to evaluate the accuracy of the actual 2020 data products and to be able to evaluate fitness for use for a variety of use cases. There are a number of forms that kind of guidance, that fitness for use and accuracy guidance could take, whether it's margins of uncertainty or standard deviations or simulation-based measures. We're still working out what the best way of providing that accuracy and fitness for use guidance is, but we've committed to providing some mechanism for our data users to do that.
Thanks, Michael. And then the last big theme was about DHC. Folks want to know, are we working on a different sort of algorithm for DHC? Have we set the epsilon yet? What is the schedule going to be for when sample data is available for DHC, the data products that come a little bit further down the road? Can you speak to that for just a moment?
Yeah, excellent questions. So as we previously discussed, with the operational delays and operational schedule changes that came as a result of the COVID-19 pandemic, we had to separate the disclosure avoidance production for the redistricting data file from the production of the demographic and housing characteristics files. As a result, the demonstration data that we've released is limited exclusively to the redistricting files. We will be doing a similar process with the DHC of tuning the top-down algorithm to meet the priority use cases for the DHC, and we will be releasing demonstration data, including privacy-protected microdata files and detailed summary metrics for the DHC for data users to evaluate and to provide feedback to help inform decision-making about the parameters and privacy loss budget that will be used for DHC. That is being planned currently. We're working on the final schedule for what that production schedule is going to look like. As soon as we have that schedule nailed down, we'll release information to the public about when you can expect demonstration data, when we'll be soliciting feedback, et cetera. So that work is ongoing. We should be able to release a schedule soon for the DHC, but we don't have one to share publicly right now.
Thank you so much. And very last question, there were a few questions in the Q&A asking, will there be additional summary metrics for the DHC products further down the road on things like kids, on other metrics that are more applicable to that file? And as Matt said in his presentation, of yes, those tables will be filled in, and if people have feedback about additional metrics they'd like to see, we would love to hear that feedback as well, especially during our stakeholder engagement process on the DHC files. So with that, I will toss it back to you, Michael, to wrap us up, and thank you so much.
Okay, thank you, Megan, and just want to thank everybody for attending today. I think we had some great questions in the chat. Thanks to our star presenter, Matt Spence, for the walkthrough of the detailed summary metrics. Please remember to tune in for our final webinar in this series next Friday at 1 p.m. Eastern, when we'll be looking at our analysis of the demonstration data for the Redistricting and Voting Rights Act use cases. And with that, I will say thank you to everyone, and this concludes today's webinar.